Good afternoon. Thank you very much for having me today. I will be speaking about a research program that I've been working on for about 2 years now. I'm an economist by training, and I've also trained for the past 3 years to look at risk assessment to analyze risk-based regulations. The research program that I've been working on for the past 2 years is on process objectivity of public policy. Specifically today, I will be applying this concept to the peer-to-peer economy regulations, specifically the regulation of the transportation economy. And looking into the philosophy of science, I found two concepts of objectivity. What is objectivity in science was my question. And the very first one that came up was product objectivity. Under this definition, science is objective when its products, theories, laws, experimental results, and observations constitute an accurate representation of the external world. The second concept of objectivity that I found is process objectivity. Science is objective to the extent that the processes and methods that characterize it neither depend on contingent social and ethical values, nor on the individual bias of a scientist. Well, what does that really mean? Let me explain first the easier of the two concepts to explain. Product objectivity. So what's an example of a product objectivity? Let's look at this picture closely. Almost all of the science that brought about most of these products that we see, the dumbbell, the chair, the shoes, the prosthetic legs, that's basically a product, and therefore the science that went into making it happen is a product objective. Okay? I also argue that if we are looking at the effect, for instance, smoking on incidence of lung disease, lung cancer, that's also a product. And the science that we do to analyze this issue is product objective. Well, why? Well, because we're defining a risk here to be incidence of lung cancer. Therefore, that's the product, and we look at those numbers. Now, the second concept, process objectivity, is a little more complicated. It's the one that we don't experience every day. And I decided to explain it by bringing insights from theoretical physics, and a very famous theoretical physicist for that matter, Richard Feynman. Richard Feynman was asked to conduct an analysis of the Challenger disaster. He was asked to explain or help explain why did the mission fail? Why did the Challenger not come back home safely? And for Feynman, he found that there is a violation of the objectivity of the process by NASA, and that's what caused the Challenger disaster. More specifically, I want to crystallize the idea by explaining the avionics system. The avionics system, and that's an explanation from Feynman, is basically everything that, for instance, a pilot looks at, all of these computers. And the avionics system takes care of the mission from the time it takes off until it comes back home safely. So in order for us to understand the avionics and all of these variables that interact with the spaceship, and some of them we don't even know because it's a venture to space, we set up 4 computers. And all 4 computers receive the exact same input. They're reading the same inputs and they're processing the same inputs. Why do we need 4 computers? Well, because we don't know the outcome. And when we don't know the outcome, we use process objectivity. So all 4 computers are necessary. And we stop them at a certain time. And we look at their output. Do they all agree? Because they're all following the same exact process. Mathematical logic and many lines of codes, the exact same lines of codes. So when we stop them and look at all 4 and one of the computers don't agree, we have to eliminate it from our sample space. And we have to only let 3 computers run. Why? Well, because the computer that we eliminate is likely not to be following the process correctly. because the likelihood that all three computers violated the process in the exact same ways that they agreed is very minuscule. And therefore, we eliminate the computer that doesn't agree and we let them run. Then we stop them one more time and we look at the output. They agree, continue. If they don't agree, we have to eliminate the source of disagreement, and therefore the source of the disagreement is eliminated, and now we have only two computers. But unfortunately at that moment, we have no way of adjudicating between the two. Which computer is following the process correctly? We don't know. And therefore we have to abort the mission. That's process objectivity. We set up the redundancy not to figure out which computer is giving the wrong answer, but to figure out which computer is most likely not to be violating the process, because we don't know what the correct answer is. That's procedural objectivity, because we cannot look and see the input. That's in contrast to product objectivity, when we have a product in mind, like the prosthetic leg, and we zoom in our process to achieve that product. We know what it is. How is that concept from theoretical physics going to translate into economics analysis of public policy and regulations? For theoretical physics, when there is a violation of the process, the spaceship explodes and we can look at it. And we can look at this incidence and learn from it. In public policy, most of what we're doing is a counterfactual. And most of the time, economists and public policy analysts are looking at the dark. We're staring at the dark, at the counterfactual. But that means that the fact that we have to follow a process is even more important, because we don't know what the outcome is. So we have to set standards, procedural objectivity, that we follow consistently and transparently, so in hope that when we do that more and more, we are zooming in on the truth. So what is this procedural objectivity of public policy? What is that process? Well, we have to always start out somewhere. Yes, we don't know the outcome, but we have to start out with a method by which we can accomplish the outcome. The first one is regulatory best practices. This is the stock of knowledge that we have right now on how to approach a particular issue. Now, they're not best because somebody said they're best. It's because this is our stock of knowledge as we have it right now. But as long as new evidence and our stock of knowledge is increasing with time, and we have competition of idea that points to one practice that may be not appropriate in a particular instance versus maybe a practice that's not appropriate at all, and we update our stock of knowledge, that allows us to do retrospective review, look back and update our knowledge, and that feeds into what we now constitute the new best practices. So the best practices improve over time and become better and better. Now let's transition into new technologies. New technologies, whether it is Uber, whether it's Airbnb, whether it's driverless cars, or even pizza boxes that are being dropped at our doorsteps from the sky, literally, all of these new technologies create risks just like anything else. They have uncertainty associated with them, and these uncertainties create concerns, especially from the regulators. But the question remains, is our stock of regulations appropriate to apply it to these regulations? We don't know the outcome, so we have to follow a procedure. So let me zoom in on one particular regulation. Taxi cab regulations. And I'm going to zoom in further to Austin. Taxi cab regulations, by the way, have been with us for over 100 years. But in 1984, the FTC has written a document that outlined the procedure by which these types of regulations can be justified. And the procedure is basically to outline the set of market failures that would likely occur if the market was left to on its own with free entry and exit and competition in the taxi cab industry. Market failures such as inefficiently high rate, lower quality, asymmetry of information that might drive rates higher and quality lower, among other things. The FTC at that time did not find ground for these regulations. There was just simply not sufficient evidence that the counterfactual, free entry and an exit, free competition, would lead to all of these problems dramatically enough to justify the regulation. But nevertheless, that was the process. And local and state governments, many of them adhere to that process. In other words, this is our projected list of market failures and we need to interfere. But that was before Uber and Lyft entered the market. That was before the creation of this parallel market. Uber and Lyft made the counterfactual factual. So the question now, is this now appropriate? Does our stock of knowledge right now say that our old regulations that are applied to the taxi cab industry appropriate for Uber and Lyft, these technologies that we don't understand quite yet? Now, when I looked at the taxi cab regulations in Austin, I noticed that there has been violation of process even in this controlled environment. So, the taxi cab regulation in Austin said that we need to control the entry into the industry. So we're only going to allow, let's say, 2 or 3 companies to operate. Okay? But we have to be careful because we want to allow for competition within this limited market. So not a single one of those companies will gain beyond a certain point of a market share. That point is actually 60%. But even with that, there was a violation of the process. For instance, Yellow Cab has 68% of the market share. Okay? But still, there is something fundamentally deeper here. And the fundamentally deeper thing is the parallel market, the counterfactual that became a factual. We need not to jump in from old regulation to applying the same regulations to Uber and Lyft, because if I was a regulator, I would use that parallel market to see if the process by which I justify taxi cab regulations is still in place. Do all of the market failures still exist? Uber offers the data from Uber and Lyft and the other companies that will come through. All of these, the companies are providing great data points for us that we can study. Is the price, in fact, higher? Is the quality lower? Is there safety concerns as we have thought? Do all of these market failures still exist? That's what we need to look at right now. I would like to leave you with a great quote from Richard Feynman. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. And I think this can be rephrased and applied to public policy as well. Thank you very much.